Welcome to the review video on exponents and logarithms. First, I want to just talk about why these would be grouped together. Hopefully you remember that they are inverse functions, as you can see on the graph right here. Y equals e to the x is shown along with y equals natural log x, and you'll see they're a reflection over the line y equals x, and so they are inverse functions that undo each other. Now, for years, people have always said that it's in calculus that they really master their algebra skills. And this is particularly true for exponents, where the properties of exponents are something you're going to be using throughout the course in every chapter. It is not something isolated in a single chapter like in previous years, but one that is used constantly. So let's jump forward and review what we should know about exponents. All right, in this first slide, we're going to be considering negative exponents because we do need to keep these straight. And so we'll just refresh our memory as to how we remember how they work. And one of the best examples is to start with something we know. 2 to the first is 2, 2 squared is 4, 2 cubed is 8, and we feel real comfortable. And as we go up, we're multiplying by 2, which means if we go down, we're going to be dividing by 2. And using that pattern, we get 2 to the 0 equal to 1. And recall that it isn't just 2 to the 0 that equals 1, but anything to the power of 0 equals 1. So now I'm going to divide 1 by 2, and I get 1/2. And I divide that in half, and I get 1/4. And I divide that in half, and I get 1/8. And you can see that this was actually equal to 1 over 2 cubed. This was equal to 1 over 2 squared, and this was equal to 1 over 2 to the first. So that brings us to our negative exponents. If I have a to the negative n, that is equal to 1 over a to the n. And sometimes we might see something like this, 1 over a to the, let's make it negative, we'll make it negative m, then that's going to be the same as a to the m. All right, so let's try this out with some problems. I would suggest pausing and coming up with these answers on your own. All right, welcome back. This first one we should note is going to be 1 over 5 cubed, which would be 1 over 125. In this next one, a negative we can also think of as flipping the fraction because 1 over 2 becomes 2 over 1. And now my exponent is positive, and 2 to the 5th is 32. Now, if you don't know that right offhand, I suggest just keeping track of your powers on your fingers. And so when I raise up my first finger, I'm saying to myself 2, 4, 8, 16, 32 when I raise up my fifth finger. So this is my hand here, right? There we go. I'm not really an artist. All right, so there's my 5 fingers, and I go through. When I get to my 5th finger, I said 32 to my head. So that's how I do it when I don't remember them. And then this last one is, again, that flip idea, 3/2 to the positive 2, and then I square both the top and bottom. So 3 squared is 9, and 2 squared is 4, and we're done with those problems. All right, the next type of power exponent that we want to keep straight are fractional exponents. And the rule of thumb we're going to use on these is to remember that on top we have the power, and the way I'd like to remember this is power lines are above ground, and below we have the roots because generally speaking, roots are below ground. So if you have trouble remembering which is which, just remember the power lines are generally above ground and roots are below ground. So let's try this out. So again, if you think you know how to do these, please pause and try them and then check back as I go through them. All right, welcome back. So what we're going to be starting with is 32 to the 1/2. The 1/2 power means the square root of 36 because 2 is a root and a power of 1 doesn't change anything, so that's simply 6. In this next one, our root is a third root, or a cube root of 64. And of course, I know that 4 cubed equals 64. Therefore, my answer here is 4, because 4 to the third gives me 64. All right, now this next one, I have a root, the square root, and I have 25 cubed. Now the question is, which do I do first? Well, I'm doing this without a calculator, and I don't actually know 25 cubed. And I like small numbers, so I'm going to take the root first. It doesn't matter which I do first, but I like to take the root first because that's much more manageable. The square root of 25 is 5, and 5 cubed I know to be 125. By the way, you should know all of your powers of 3 through about 6. 6 to the third is 216, and 4 to the third is 64. Those are ones you should just know off the top of your head. You should know your squares through probably 15 would be a good place to stop. All right, this next one, we've got the cube root of negative 27 squared. All right, so since we're going to be squaring it, we know it's going to be positive, but again, I'm going to do the cube root first. So the cube root of negative 27 is negative 3, because I know negative 3 to the third is negative 27. And then I'm going to square that, and I get positive 9. All right, let's move on. Now we mix them up. We have negative and fractions all together. So again, a great time to pause and try these on your own. All right, welcome back. Here we go. In this one, negative 3/2, I've got to flip it. I've got to take the square root and cube it. And if you followed all of that, you know that we're going to have 1/64. Yeah, so I'm going to break this down for you though. So 1 over 16 to the square root of 16 cubed. So the negative, put it in the bottom. My root is 2. My power is 3. So I've got 1 over. I'm going to always take the root first, get that smaller number. Square root of 16 is 4. 4 cubed is 64. All right, let's try this next one. Again, I'm going to flip it. So I've got 9 to the 1/2, which is a square root, which is simply 3. And then one more. Here we go. I've got the, let's see, 1 over the 4th root of 81 cubed. Now, a good trick for a 4th root is a 4th root is really 2 square roots. So you may say, well, I don't have my 4th powers memorized, but if I take the square root twice, I get there. So square root of 81 is 9, square root of 9 is 3, 3 cubed is 27. And there's my answer, 1 over 27. All right, now we're going to move on to logarithms. And we're going to be working always with, well, not always, but nearly always with natural log and calculus. So that's our favorite logarithm. So when we see ln, we know that the base, which is not written here, is the letter e, one of our favorite numbers in calculus. So when you see the natural log of a, which is what's up here, you're asking yourself, e to what power is a? So you're saying e to what power equals a. Remember, a logarithm is a power. And in fact, a natural logarithm is a power of e. Okay, so let's take a look at what this means. So in this particular slide, we're going to look at some basic ones. The natural log of 1. Now, it turns out it doesn't matter if it's natural log or any log. The log of 1 always equals the same number. But in this case, we'll think of it as being e to what power is 1, and e to the 0 power is 1. So our answer here is 0. And our next one, we're going to say e to what power. So let's do that over here. E to what power equals e? Okay, this is almost too obvious. That's right. It's going to be 1. E to the first equals e. All right, so our next one, we're asking e to what power is e to the x? Again, it seems almost too obvious. There it is. It's x. E to what power is e to the x? E to the x is e to the x. Now, I also want you to take note here, though, that we were applying two inverse functions. Our function ln and e are inverse functions. So when I take e to the x and then apply ln x, I'm applying inverse functions. And so all I end up with is what I started. I started with x, I took e to that power, and then I took the natural log of it, and I get x. All right, so really the same thing's happening here. These are inverse functions, only here first I'm applying ln and then e, and so my answer is still x in this case, because if I apply inverse functions to x, I just end up right back where I started. All right, so let's move on to these problems. So when we understand the relationship between ln and e, we can evaluate these very easily. Our first one is simply 5, because we're always looking for the power of e to answer this question. All right, our next one, well, if we understand our powers from just a moment ago, this is the same as e to the 1/4 because I'm taking the fourth root. Therefore, my answer is 1/4. And then this next one, ln of e, let's see, power lines are above ground, roots are below ground, so there's my fraction, 3/5, and that's my answer, is 3/5. All right, so now we're going to combine some other things we learned before because now it's in the denominator, but I can rewrite that as ln of e to the -6th, which means my answer is -6. Or here we've got a root, a square root, and it's in the denominator, so that's e to the -1/2, so my answer is -1/2. All right, so we've practiced evaluating natural logs with powers of e. And then the last thing we want to do is recall our log laws. And this will be used here and there in calculus, but they're ones that you just really need to know all the time. So if I'm multiplying two numbers in my logarithm, I can switch it to an addition. That's because when you're multiplying two values like x to the n times x to the m, you add exponents. Remember that a logarithm is an exponent, so its multiplication turns into addition, much like when we multiply here, our powers are added. So division becomes subtraction, and then ln of a to the k turns into multiplication, just like when we have x to the n to the m, we multiply the powers. So here we've got a power to a power, and we multiply our exponents, and that's why these rules work. All right, so just to make sure we've got those down, here's a little exercise for you to fill in the blanks. So pause and think of what numbers could go in those blanks. All right, welcome back. And I just want, hopefully you realize there's more than one answer for these. And so there's many different ways you could have done this. Perhaps you put in 4 and 3, or maybe you did 2 and 6. So a few answers there. Here, anything that divides to 2. So for you could do something like 10 and 5. You could do ln of 4 minus ln of 2. You could do ln of 100 minus ln of 50. Those would all be equivalent to the natural log of 2. And here, let's see, well, if you realize 64 is 4 to the third, you might have done this. Or you might have said, well, 64 is 8 squared. So that would be this one. All right, that's it for this lesson.